about how it can be shut down and why we need to think why it should be shut down or not. So I'll speak about this MT shutdown technology. Have you ever heard such a name? Yes, it's good. What is it? It's a it's a hidden processor in your system, and Intel puts its code in there, the code that no one actually sees, and this code runs at all times, even if you have just power on system. It has access to memory USB controller. It has access to other devices. It is present in all of the machines, in the very old machines. You cannot find it in such machines. You may ask this question, why do we need to shut it down? In actual fact, it's a philosophical question. Each of us may be a little bit paranoid, and sometimes I don't really want that a code is run on my machine that has access to my data. I could not really control it on the one hand, and formally everything has errors and mistake. It's the hardware complex. It may also have some hardware errors. As a result, your system may be vulnerable. It may have some vulnerabilities, and you might want to shut down the ME before they fix the updates or forever. MT has a number of horrible functions like remote control, NCC. It also has some hidden service partition. It's not an announced technology, it has been patented, and we may only find something in these bridges. It undocumented interfaces and closed implementation. As a result, no one can check and verify all these things. And seems like it's a pig in a poke. It's done by the vendor, and sometimes they don't do it properly, and sometimes the Chinese manufacturers hide something. And hidden service partition, ME and AMT, allows to create pieces and bits on the disk, hidden ones, and simple operating system just doesn't see them. It is intercepted and emulated, so you don't really see that there are some service data, secret data regarding the users. It's just like a closed container that the operating system just doesn't really see, and this is the official schematics. MT also initiates some other functions. Apart from the potentially dangerous functions, it has a bunch of legal features, like integrated clocking, so you cannot really shut it down simply, so it does not affect the system. It is used in DRM. It has some package filter which intercepts the traffic and sends it from there. In actual fact, it's all used for remote administration, so that the administrator does not go to the computer, go to the web browser, click on some buttons, and everything works. Right now we'll just show you some ways that we have created 6 ways actually of shutting it down. Failure of DRAM init done, DID, via me flash region update mechanisms, soft temporary disable. We also found a command which allows us to shut down disable ME on the fly, and we may consider disruption of ME access path to UMA. We'll speak about how to shut it down, and the simplest way is the corruption of ME flash region. Now I'm going to tell you about these definitions. MT, ME, Intel V Pro. ME is an environment consisting of dedicated hardware and firmware components. MT is a firmware application running on the management engine. vPro, a marketing name that covers a wide range of security and management features that are built in Intel processors and chipsets. Historically, ME and MT are mixed together in terminology because Intel called this technology MT, then it started using ME, so we'll be using some different names, and when it becomes critical we'll be given some comments. Later you'll be able to check our presentation and clarify things. In the beginning I would like to briefly explain the MT evolution and its block scheme, the hardware part. That's what we call ME. The technology was designed as a non-mandatory one, which runs on a separate chip. It's not on the south bridge or north bridge, but it was on a dedicated chip, and on that chip there was an embedded network controller interface. That was the chip which was connecting SM via the system management bus with the south bridge, and this embedded controller was responsible for MT functionality, did not have access to system memory. SM bus was reading the sensors from the south bridge, and it had dedicated access to SPI flash, where it kept the configuration settings in non-volatile memory. Then we started having serious architectural changes, and MT, the embedded controller, which was initially called baseboard management controller, it was entitled management engine. It was put on the south bridge into the memory controller hub, MCH. It had received the rewritten firmware which was stored in the SPI flash region. Part of the functions as ROM remained, but these functions are really limited, and they only required to check for the integrity of the main firmware. The management engine developer is equipped with a very important feature. It has some embedded DDR memory controller, and it has access to all of the controllers in the system. The management engine capabilities have become limitless. Starting from 6.0 version, in MT we started serious changes of the Intel platform. The DDR controller, the system controller, was put on a separate die with a CPU. Luckily, management engine was not put onto the same die with a CPU. It remained in PCH. And the need for the North Bridge had become redundant. The south bridge was renamed into Platform Controller Hub. Management engine had to use the system memory through DMI bus mechanisms. There is a misunderstanding among hardware Intel engines that management engine still has the uncontrolled access to all system memory, but it's not true in the modern systems. Management engine in this or that configuration is present on almost all of the modern systems with the MT 6.0. It has not been modified seriously. I will start with the disablement techniques. These are the disablement techniques that really work and they do shut down AMT. The first one, the failure of DRAM init done. We have the so-called UMA area. I would like to speak about unified memory architecture. Management agent has the embedded management engine, and it has to have dozens of megabytes for normal performance. For this, it needs some part of the physical memory of the host to be used as a cache mechanism, like virtual memory in operating systems. This part of the physical memory, which is called UMA, is a stolen memory, so it's hidden from the host. It is used as swap, like paging file in Windows. Code pages integrity is checked by private CRC algorithm. UMA data pages are encrypted. Management engine accesses UMA via PCI Express virtual channel, VCM mainly, to get access to UMA. Management agent cannot initialize the system DRAM controller, and they have a special agreement on initialization. Here's some initialization scheme that we are showing you here. This is the initialization scheme and how it's happening with time and what the functions taken by the host and the management engine. What are the modules? ROM, bring up, kernel, and management engine application. Management engine is waiting till the host initiates DRAM controller, and it informs it with a special DRAM ME done message. It was quite confidential, Intel related information, writer's guide, but we found a way how to do it. It's done with the configuration space, PCI configuration space, with the management engine interface. I will speak about it. And this message has a form. It's interesting, we found this format in Core Boot project. You may have heard about it. Here's the format of this structure, and the first field is the base address by UMA, and the one before the last one is the status, which shows whether it's initiated UMA successfully. If we put failure there, management engine will not be working physically. Its static memory is very small. We only need it when the host is disabled and it has limited functionality. So it's interesting that in the official Intel documentation they state that that's a general status of host, and that this field is not used by hardware, but in actual fact it is used. That's the bring up module scheme. We have a timeout guide. If during some time the host does not send the guide, management engine goes into the timeout mode and cannot function any longer. So we all have access to BIOS. So the first instruction, we utilize a big cycle for like 20 seconds, and then management engine will not work. Or we may find and change just one file and send failure instead of success. Maxim will speak about the second method more in detail. The first idea which occurred to me is that the management engine really updates and is actively using Flash. As a result, the story goes as this: when you update it, not with the management engine, but like for example, it's done in BIOS or in the manufacturer's software, in actual fact, the Flash access should be blocked. When you block the Flash region update mechanism, like Mark was speaking about UMA, you cannot measure the CRC of the page because it contains the special private data, and the conclusion is made when you update the management engine, you deactivate all the functionality, all the functions. What are the mechanisms available to imitate this update? We found two. The first one is a real good hardware method. You just find a jumper, and with the jumper you short circuit some contacts at the PCH card. Use a special jumper. PCH perceives it as the programming mode. ME deactivates. You can do it by software, special command sent by BIOS. Some BIOS has advanced features, and you find the ME disable command, and it sends a special MEI command to Intel ME, so it stops working. With Series 100 security override, it's stated here, flash descriptor security override. They started pointing it out, which they didn't do before. And the actual interface will be covered by Mark. I will speak about MEI, Management Engine Interface, because all of the commands are sent by the use of this interface. Initially it was called the Host Embedded Communication Interface. From the host side, the host views it as the internal PCI device with a BDF 022001. Communication performed using ring buffers, accessed by MIO registers of MEI. Through this interface, applications communicate with host applications, and they exchange unique client IDs, hard-coded in firmware. Each client ID defines the structure of messages passing through MEI. One of the main client IDs is the ME kernel host interface, MKHI. Its kernel It's done by the kernel. All of the identifiers of the clients shown in core reboot project, and here's the structure given, which is the header of all of the messages sent. Inside the structure, the first field is the identifier of the group. The commands are split into certain groups, and the first group of commands that we need is here. Host ME region flash protection override. It's the firmware way to rewrite the region on flash. Here we have the identifier, put it in the binary mode to send this command. This command has a very important limitation. HMR FPO lock. The proper BIOS should send this lock so that the attacker does not send commands to rewrite ME region. It takes effect after next reboot and works only before a subsequent reboot. One such session, like Maxim was saying in some BIOS, we have a management engine region reflash which sends this command. Number 3, soft temporary disable. Some BIOSes have this, and I would say the whole majority of BIOS has it. We also did some binaries here, the group of commands, binary sequence. It should only be sent before end of post. We have this mentioning end of post. BIOS sends this message to the management engine, stipulating that it's done before end of post. Soft temporary disable command is sent, and after that management engine goes to a specific state. It writes in its non-volatile memory, and after that all of the reloads and management engine will not just function. The bring up module, in order to recover it, bring up module, you need to send another command which has slightly different structure. Its specifics is that the senior byte should read 20. In this state, if the management state software memory disabled, soft temporary disabled, there is the option disable me that performs temporary soft disable. Maxim will pick up on the next way. Thank you, Mark. There is also a mode when you are a vendor, when you develop your hardware, and you need to have some debugging mechanisms. And here is some debugging mechanism that we found. It's called manufacture mode, which is interesting. If your system operates in this manufacture mode, you can shut down ME at any time and send this command. This embedded processor will shut down. It does not need restart. And the function of ME is huge. The vendors would like to update some settings on the go, on the fly, written flash, and And lots of computers utilize this mode from the box. When you're in such a mode, like Mark was saying, when he was explaining the previous shutdown modes, when you send this command, like this one, which protects you from changing the configuration, ME starts ignoring it after that. As a result, if your system is already in manufacture mode, you just simply send a command on the slide, like it's written on the slide. If it's not, you can do another thing. You can download BIOS and cut out the ME region out of it and put it into a special Intel software, put a tick, manufacture mode, and after that you can power off, power on manufacture mode. We found a command and we wanted to try and see how this tick looks like, by the way. Which hardware has manufacture mode activated. So seems like all of the Apple devices, Lenovo, some motherboards which are very popular, have this manufacture mode in the wild, so to speak, and the vendors tend to forget to lift it off. And this is a malicious vulnerability which can be used in a malicious way, and you can rewrite some flash data, change the region, so bring it back, go back to Mark. Breaking ME access path to UMA. Management engine accesses UMA by means of PCI Express virtual channel mechanism. By use of the PCI Express virtual mechanism, you can disable them. It was really a revelation for us when we were able to write a 0 and we disabled 1, and management engine hung. But bad news, after 40 seconds platform is powered off. Any debugger can try and do it and find this point in the documentation. So you have 40 seconds safe in the safe mode, and then it's powered off. And if you put it back, it will be powered off, and it will be powered off completely. You just need to take a reboot. Some exception runs and it slips into an error mode. Why it shuts down in 40 seconds? Obviously there are some power management option initiates. Without being able to put it into another power mode, it's just completely shuts down power. And the last thing will be covered by Maxim. This is not an operational method, but obviously everyone has asked this question. What if we just simply destroy the management region? What if we just cut out, corrupt ME flash region? What if we just cut it out and launch the system? What's going to happen? Management engine manages some peripherals. You can tune it. Okay, you just disable it, you cut it out, and we brick the device looks like, well, the fan is not spinning. It looks like a brick, but it's not that bad. The system is loading. If the if the BIOS is working properly, management engine hangs in this bring up area, bring up phase. And bring up is on flash. It hangs in ROM, and that's it. And after that, and we have a more tricky way of cutting out this region that we can speak about, which helps us save some functionality. So the fan will not spin, BIOS hangs, the processor, the CPU may heat up, so it may damage your CPU by heat. So you are shutting down the cooler by this way, and you actually don't see that the system is loading because the lights are off. So you cannot actually identify that the CPU has been initialized, and as a result, you don't see any messages about error. You're waiting and waiting and waiting for like 30 minutes, and then it's done and gone. So there are three ways actually to corrupt this flash, and yet one more allows you to do this thing. You just wipe out the region, the system loads in this special state in 40 minutes, and this state ME performs platform shutdown. 40 minutes, not 40 seconds, so it's easy and you still have time to do something on it. May I ask this question? So we showed you some methods, we sent some commands to ME. We actually have this black box, how we really show that it really shuts down. We cannot prove it, strictly speaking, but there are some features. One of them being like this one. When we combined two methods, UMA memory, UMA mode, that you can do online, and the ones with commands that we have described. So if your machine reboots after all that, seems like that something still works there. If it doesn't, we broke it nicely and accurately. Maybe it does not need UMA, but UMA is used as kind of a paging file for ME. Otherwise, you will be just taking some data from the processor, not only data but code. If it does function on a processor, there will be a fault and your system will shut down. So that's how it shuts down. It's just like on Windows, you just delete the paging file. What's going to happen? So it's similar. And there are many other features like non-spinning fans, etc., etc. vPro, which is malfunctioning. And we would like to demonstrate this to you. It's a demo. This is the KVM technology. There is a system administrator connects to a different machine, and get some images from the remote machine and can perform some activities. So it's a key logger. You see what the user is hitting. So the live system is on the right. On the left is the VNC connection, and we can see what's happening there. So you can connect a remote disk. ME will emulate it and will launch the operating system. So there are some activities happening. The system administrator does not see it, so you can hide. So the next connection is also faulty. The connection engine does not really work after reload.
Нет, ну там нашу программу линк.
After restart, rather. You may actually launch our software, our small software, and it does what has to be done. Well, we were thinking about making this open utility, but you sound very convincing, so we might think about it. So we showed you a demo. If you have vPro, if you would like to avoid the system administrator, you can do it. So if in modern platforms, ME can't be disabled by removing DDR modules from slots of channel 1. So they changed that. It's not like they used to have before. There is an Intel tool which allows vendors to tune this ME. It used to have a flag shut down, but it was a long time ago, and it's been a long time since, and in the contemporary versions it's not like that. And this documentation, which is copy-pasted from Intel, it says it's the flash descriptor signature is corrupt. It does not allow SPI flash controller to work in a non-descriptor mode. We tested it at a few machines. After that, PCH would not function. It does not distribute power in version 9, version 10 and 11. It does not really work. So conclusions are, there is no silver bullet to deactivate ME. Some of you may be fortunate enough and find out whether your machine is in the manufacture mode.
На самом деле только одна машина на Skylake. То есть вот как-то так. Значит, ну на худой конец, на самом деле вы всегда можете эту...
Or in actual fact, you can put that tick if you like. If you would like to allocate some time, you just put a tick there, flash the BIOS, and you can shut down it online. And you can do it by the vendor firmware. ME firmware of the two types, 5 megabyte one and 1.5 megabyte. 5 megabytes it's with vPro, and 1.5 megabytes is the rest. And these functions are actually everywhere. We have it everywhere. And all these methods can actually be used as the DOS for your system administrator if you would like to avenge on the person you hate who closed you the Facebook access. You can do so, and this vPro was actually developed with one of the purposes. So whatever the user does on the machine, the administrator still has access to everything. The machine should work regardless of the host. You need to be able to take away the keyboard from the user remotely. Use these methods, or somebody else may use these methods to control the machines. Thank you very much. That's all.
Сейчас следом, окей?
Спасибо за доклад. Чем грозит отключение?
Thank you for your presentation. If we shut down ME, what's going to be the outcome? You can sleep, suspend it, enhance the performance of the PC. I don't remember, and sleep used to work in some versions. The main thing is that this controller is loaded once. So once it's loaded and everything works more or less fine, then ME actually dies away and the device is configured, basically. Thank you, ladies and gentlemen. Thank you. If we perceive these, it works at server platform as well. If we just perceive it as a backdoor, and this backdoor can be used by evil Americans, for example. I was thinking about these evil Americans using this backdoor for many nights. Maybe on day X, some evil Americans from planet Nibiru would like to conquer all the server platforms showing IP addresses to the internet. What may it look like? I think AMT with some payload with the Ethernet card. Well, it's all encrypted, but what about non-documented function? You have this channel vPro, it's all encrypted. Okay, seems like everything is closed with firewalls apart from these key services. As an example, and it relates to ME in the recent platforms, you send this package and that's it. And you need to be in one segment, but obviously you have a host and you can only send an IP packet there. In theory, can it find the access from the card? It only operates on the genuine card. Why? Well, because judging from the scheme, the actual filtration, OB filtration, is realized in the embedded network cards. If you use external PCI Express network cards, ME will not get this management function to start blocking. This mechanism has been done by anti-thief. Your computer is stolen, you send an SMS message and your computer, which is stolen, stops functioning. Simple as that. Intel cards also have them. I'm talking about the third-party manufacturer, and it would be nice just to see the specification and the chip. And this is the anti-theft technology. If I would like to expand this system, if I would like to, well, if I imagine my computer is stolen, your solution, the thing that you are describing, is checking the host operating system memory and crafts the TCF packets So if the disks are all wiped out and deleted, I can still track down a certain process. Is that possible? I think it is possible. The actual information is stored in a flash card, SPI flash. Even if your disk is completely destroyed, you can send this poison pill. But to send this poison pill, I need to know where to send this poison pill. Well, the story goes like this. In some of the notebooks, you can insert a SIM card. So this solution supports this SIM card support, and it calls you and it's stolen, and the information may be deleted. As far as the tracking is concerned, yes, but whether Intel is going to do it, I don't know. There is a very interesting detail as well. We might want to address the recent developments by Intel. They are trying to put the 3G modem on a die. So make your conclusions. There is another thing, NFC. You may have control over your computer. You put your proximity card, transport card, and by using radio module on the die. So antenna, what about antenna? Antenna may be put on a circuit board. I've not seen computers with NFC, but this technology is already available. It's still there. But I'm going back to my first question. Just in theory, theoretically, for some governmental applications, for those of people who are very much worried about external threats, is it possible to track it down in theory? Can we just track down this payload, or we just in the automated mode, or it should be done on a step-by-step basis? So you just check and verify every packet. If the PPS rate is huge, there will be a huge payload on your CPU. We have certain markers. We have not reversed this protocol. Thank you very much. It was a very interesting presentation. I would like to speak about this track. Some of the people are creating this for Windows, and they put special anti-theft executive file, exe file. If you just restart your machine, if you just put in a new system, it will be adding another executive file. You don't need to do much. You have access to the memory, and that's enough. Thank you for your excellent presentation. When you shut down ME, have you ever tried to see whether the packets get to the promiscuous card? You shut down ME, and it seems like that the packets should go to promiscuous card. They shut down MIT. We did not check. We did not check it. It's a good idea. We will do it. A very quick question. What about AMD CPUs? We didn't try it. They're developing a similar technology. I think it's all very similar, just the name is different. During your presentation, you mentioned neutralizing, that in one case the system reboots in 40 seconds, and in 40 minutes. This number 40, is it by chance? Or maybe 40, 42. I think the first 40 seconds you see there is that this ME is based upon something. So ME checks the power, twiggle with the clock rate. When you simply shut down the channel, you have a fault of this system, and the system shuts down forever. When you corrupt the flash and you wait for these 40 minutes, this thing happens. It starts hanging in the room phase, and it enters into a special recovery state. And you can try and do something with it so that you do not break your machine. What about runtime methods of ME shutdowns? How often do they work? We checked it with so many cases, and only in one case it didn't work, because the manufacturers just forget to put that firmware in the non-manufacturer mode. I was surprised that all of the Apple machines are in the manufacturer mode. And I repeat, there was a special slide, we just prepared that. Just to put it in the manufacturer mode, you just need to put a tick in there, see? And it's done deliberately. Either it's done deliberately or it's forgotten. Always deliberately, obviously. What if this function is disabled and shut down? Do we need to flash the BIOS once again? If it's shut down, you need to flash the BIOS. It's important because a lot of manufacturers do not allow you to flash the BIOS on your own. So later there will be just bootguard technology by Intel, which will completely eradicate the flashing of the BIOS, even through vulnerabilities. I think the bootguard will be using some of the ME mechanisms here. And as a result, there may be options available. Thank you. Have you ever, well, to let someone control the system, like the administrator, they should be authenticated. Have you ever thought about authentication impact? Well, the password is written on flash. There's just one password. 3 actually. There are 3 passwords on the flash. If there is an error with access bits in flash memory, like for example, I have a ROM page, and this flash card can be written and flashed a few times. As a result, you can wipe it out. You can send this reset command, and we have a special command which is sent through IME and wipes out all of the configuration, including the password. It gets back to the default password. ME starts working like it did in the very beginning, with the standard default password. I see you did a lot of work, and ultimately, what's the best practice? You just go back home and you correct it. What do we start with? Well, it's not working, and it's good. But still, what would be the most effective thing to kill it? 99% of the you just buy a programmer, and put it in the manufacturer mode, even if it's not in the manufacturer mode, and then you send this command, and ME will not function. and at home without this programming device save my old grandma. If your descriptors are improper, you don't need a programmator. But what if it's not activated? Let me disclose this idea on the sideline at a different conference. I think in theory there is a possibility to do so. So seems like the first vector is just to use a programming device. You find an old machine, you find an old computer, a very old one. I would like to clarify. Have you got watchdogs? Do you think that there will be watchdogs controlling that ME is deactivated and it will be activated again? What are the watchdogs? I think the CPU, the firmware and BIOS. When you kill it like this, obviously you will not be able to get through CPU. When it runs mad, here's the point. ME does not reboot when you reboot the machine. To reboot ME, you just have to write one into different registry, where you have to say that you reset not only the hosting machine but also ME. In actual fact, when you put it on CF9, it's not quite a reboot. We don't know whether it was functional with the power shut down. We did not find any batteries. But people say that it's very low clock rate and low power consumption. Thank you for your presentation. I've been checking this technology for a few years. My dad was threatening me. I have a question. Those applets that you can put there, kernel, who can load it? Who can do it? Can you do it remotely? I should say that ME firmware is supplied by Intel, and Intel can change it. It's all signed with a closed key by Intel, so the manufacturer cannot add anything to it. And people say Apple does it as well. Can they do it remotely? Yes, they can. Send a package, send a pack. They can send it from the host. There is an embedded mechanism from the host to update it. Can we update the microcode? Yes. Thank you. You also spoke about the fans that stopped spinning. Do you think it's possible to do by software means? Manufacture mode. Well, you see, it's a classic story. Either it's a region error, the BIOS is always available from the box. You just check it, see whether ME is acceptable. You grab the image, and the fans will not be spinning.
Зло в жизни. И регионы настроены, то есть
What if the regions are set properly? If you take this command, and you put this ME image after the reboot, it's acceptable. You just need to take one. In theory, so you can a 3-pin contact with 5 volts. Here is this next question: how old should this computer be to make sure that it works quite well? MT 1.0, was it optional? Everything which was before MT 1.0, before 945 chipset does not support this technology. It may be a very obsolete Pentium 4 CPU. And it starts with a 5 series chipset. Which year is it? I think it's 2009. So I think I can continue using my computer. Where do you store the key, the public key?
Я скажу.
If I may. It's not the key that they store there. It's actually much more interesting than that. They just keep the checksum there, but not the key itself, because keeping the key in SRAM is way too expensive. It's 2048 bits. What do you want? So they keep it there as SHA-512. So the key itself is written to public ME. And the algorithm is as follows. ME will read off the key, it will calculate the checksum and compare the checksum to whatever he has in the firmware. I'm sorry for interrupting everybody here. Thank you very much for your presentation. May I ask you something? Do you think we can use flash RAM? Are there any Windows APIs that could be leveraged? No, no way, because it's fully closed on the hardware level from the host. Well, you can actually access it, but only during the early initialization stage. I'm sorry, I should have covered that in more detail. So the guys there showed what they actually did with ME code. They reconfigured stolen memory, and then they injected code into a live system. Obviously, it wasn't signed. That was back in 2009, by the way. So after that, Intel introduced data encryption and integrity control using their private CRC algo. What are your follow-up research plans? What shall we expect in the next conference? I've got no idea. We do have major plans, but I'm not sure we can actually disclose them. Does anybody know of your plans? Well, all those who should be are aware. Well, we try to sort of get their approval for our plans. It was difficult. Guys, have you tried making research into using host as an intermediary access point? Say, for example, you have a host running this functionality in the DMZ. Can you actually use it in order to spy on the infrastructure of a company? Well, theoretically speaking, nothing should stop you from doing that. Well, the only question is whether it's supported on the firmware level or not, and that we do not know. We haven't really looked into that. We're only looking at the firmware that we can get our hands on. But it can easily happen that there is a specialized company that only supplies computers to the Ministry of Defense, and their EME can easily be very different. We assume that Intel supplies them with slightly different hardware, or it could be somebody else, not necessarily Intel. Management Engine provides various services for remote access. such as WePro, anti-fraud. So I'm wondering how you maintain, how you do authentication in services like this. Could you please repeat the question? You mean module authentication? Oh, right, okay, I understand the question now. You must be asking me about module authentication. So there is a sort of a trusted loading. Are you talking about remote authentication? It's password-based for remote authentication. So there are several options, encryption and no encryption. The encryption option can be actually done. You need to switch it on. It's done over SSL. And who can get the password? The password is available to whoever configures your system. So remote configuration is an option. Just, RTFM, I'm sorry. I'm told we've run out of time, which probably means that we'll be happy to entertain any other questions you might have, but we'll do it in private. I think this one goes to agenda over there. And what about this one? Somebody